The algebraic equation we're going to take a look at is the Pythagorean theorem. Most students, including myself while I was growing up, just squared the numbers and found the square root to figure out the long side of the triangle, which is called the hypotenuse. However, when we have a right triangle, we can generalize that there are three perfect squares to form that right triangle. The biggest square has the exact same area as the other two squares put together. So we look at it and we see that a squared plus b squared then equals c squared. So we're going to take a look at to see that c is the longest side of the triangle and a and b are the other sides. So in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Let's see if that can really work to see why we're incorporating in the perfect squares to get the answer if the areas are the same. I have three different squares that have numbers in them. So we're going to take a look to see that 3 squared plus 4 squared equals 5 squared, because we took the two smaller squares and that area of the two of them should fit into the biggest square. 3 squared equals 9 plus 4 squared that equals 16, and that should give us 25, which it does. So if we were to then take this square and put the a square into this square and b into the c square, they should be able to fit in perfectly with the amount of information that we got, that the 9 plus the 16 then equals 25. Understanding the why of this equation helps us to really visualize and conceptualize when explaining this to our students. Sometimes when looking at numbers such as a squared plus b squared equals c squared, students then begin to perform the equation without actually knowing why it works. So incorporating in perfect squares to know that you have to square the number to figure out how much unit spaces within that square can help us understand when we're trying to solve the long side of the triangle, which typically is not given to us, but it should fit in when we are creating problems like this and solving problems like this that then give us information when using perfect squares to help us figure out the Pythagorean theorem.